Hey guys, today we're going to continue talking about partitioning shapes, but instead of actually drawing those lines together and partitioning them ourselves, we are going to look at some examples of shapes that are partitioned into equal parts and are not. So just as a review, to partition means that you are dividing or breaking a shape up into equal parts. That's really, really important to remember that the parts are always going to be equal. Okay, if we're partitioning into halves, that means we're partitioning into 2 parts. If we're partitioning into thirds, 3 parts. And yesterday you learned that fourths is going to be 4 parts. So being able to count those parts out when you see them is going to help you figure out whether it's partitioned into halves, thirds, or fourths. So we're going to look at these examples right here. We've got 6 pictures. There are quadrilaterals, there's circles, there are hexagons. There's lots of different shapes here, but they're all partitioned somehow. We need to figure out if they are accurately partitioned into equal parts. So I'm going to look at this first shape right here. I see it's got 1, 2, 3, 4, 5, 6 sides and 1, 2, 3, 4, 5, 6 vertices. So that means that it is a hexagon. Now, when I look at the hexagon's parts, I see that there's 2 parts that are triangles, and they look a lot smaller than this part right here. So since they look smaller, I know that that's not partitioned into equal parts. It is divided, but it's not divided equally, so that is not partitioned into equal parts. So I'm going to mark that one out. Okay, now looking at this circle right next to it, I see that those lines go right to the middle of the circle, and that really helps me see, are these parts equal? And it looks like all 3 of these parts are equal, meaning they're the same size, so that is partitioned into equal parts. Moving on. Now I see this shape. This shape is pretty interesting looking. Let me see what shape it is. It's got 1, 2, 3, 4, 5 sides and 1, 2, 3, 4, 5 vertices. That means that I'm looking at a pentagon. But when I look at these parts, I notice, first of all, this part right here is tiny. If that were a cookie and that was the part I got, I would be really upset. So I know those parts are not the same size. So that is not partitioned equally. Let's look at the next one. I see 4 sides and 4 vertices, and I notice that these sides are all the same length, which tells me that even though I know I'm looking at a quadrilateral, I know I'm looking at a square because the square has 4 right angles and 4 equal sides. So looking at this square and all of the parts, it looks like all 3 of the parts are equal, and since there's 1, 2, 3, that means it's equally partitioned into thirds. Okay. This looks like a trapezoid. Let me check. 1, 2, 3, 4 sides and 4 vertices. Yeah, that's definitely a trapezoid. And I've got 1, 2, 3 parts. Now, the shapes are kind of flip-flopped, but it still looks like those are the same size. So this shape is partitioned into 3 equal parts, because even though the triangles it's broken up into aren't necessarily facing the same direction, they're still the same size. So it's definitely partitioned equally. All right, my last one is a circle. This one's tricky. It is partitioned into 3 parts, but I noticed that my line doesn't stop in the middle, and stopping in the middle is a really big indicator that the circle is going to be most likely partitioned equally. And these lines kind of go randomly across the circle. In this part right here, this middle section definitely looks bigger than the other 2. So I'm going to say that this is not partitioned into equal parts. Most of the time when you have a circle, it's going to be partitioned this way, okay, like the peace sign, where those lines are meeting in the middle. And you can really tell by looking at the size of those shapes. So as you're doing your practice today and you're looking at the shapes that are already partitioned for you or broken up for you, pay attention to the size of each piece and make sure that each piece is the same exact size, even if it's not facing the same direction. It's the size that matters.